Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 6, Lesson 3, Exponential Growth and Decay. There are many things in the real world that grow faster as they grow larger or decrease slower as they get smaller. These types of phenomena, loosely speaking, are known as exponential growth and decay in the case of decreasing. In today's lesson, we will look at both growth and decay. Growth is increasing and making things larger at a rapid rate, and decay is decreasing, making something smaller or lesser at an exponential rate. Exercise number 1. The number of people who have heard a rumor often grows exponentially. Consider a rumor that starts with 3 people and where the number of people who have heard it doubles each day that it spreads. A. Why does it make sense that the number of people who have heard a rumor would grow exponentially? Well, put in your answer there, and I think that the more people that hear the rumor are able to spread it, so it spreads very quickly, just like a cold. B. Now fill in the table below for the number of people N who knew the rumor after it was spread a certain number of days, D. So on D, 0 days, 3 people knew the rumor. And then it doubles each day after. So on day 1, it's 6. On day 2, it's going to be 12. On day 3, it's going to be 24. On day 4, it's going to be 48. And on day 5, it's going to be 96. If you can see, in 5 days, it grew rapidly all the way up to 96 people. If you notice, it said that in the directions that it was going to double. So that means I'm going to do times 2 all the way through. Exercise 2. We like to determine the number of people who know the rumor after 20 days. But to do that, we need to develop a formula to predict N, the number of knowing the rumor, if we know D, the number of days it has been spreading. So A, for the following number of days, fill out how you calculated your values based on the extended products using the number 2. So we're going to do this by the long way to see if we can develop a pattern just to help us create the formula. So on day 0, my N is 3, so 3 people. So on day 1, my N would be 3 times 2 because I'm doubling it, so 6 people would know. And what we're doing is is matching it up here to verify that we are correct. On day 2, it would be 3 times 2 times 2, because that's whatever I had on day 1 times 2 again, which would equal 3 times 2 times 2, which would give me a total number of 12. On day 3, it would be what I had on day 2, so it would be 3 times 2 times 2 times 2 again, which would give me 24. So don't forget, all I'm basically doing is that this 3 times 2 times 2 is what I had on day 2, which is another way of writing 12. I could always substitute the 12 in for there as well, but they want to make sure that you understand the pattern that is going on. So on day 4, I have what I had on day 3, so I have 3 times 2 times 2 times 2, all in parentheses, times 2, which is going to give me 48. And then on day 5, I have 3 times 2 times 2 times 2 times 2, all times 2 again, which is going to give me 96. B, using the pattern you developed in A, write a formula given the number of people who know the rumor and if you know the number of days D. It has been spreading. So we're going to start off by saying N equals, and we got to figure out my pattern. What is the day that I started with, or what is the time I started with? Start with 3. So no matter what, on day 0 I have 3 people. Then I'm multiplying that by what? What did I multiply each day by in my pattern? I multiplied it by 2. So I put times 2. And the thing that changed was how many days it is. So my days, my d, is going to raise it by exponential. How many times I'm going to multiply that by. So if you look down here at day 5, how many 2's do I have? 1, 2, 3, 4, 5. I have 5 D's, or 5 2's on day 5. And that's true all the way. On day 1, I had 1 2. On day 2, I had 2 2's. On day 3, I had 3 2's. So does that make sense of why the D is raised exponentially? Because that's how many 2's I'm going to be multiplying it by. C. How many people would you know the rumor after 20 days? So let's use our formula here because it's the easiest way to do it. N equals 3 times 2 raised to the 20th power. In your calculator, you could type that in exactly how you see it. Don't forget the caret button in your calculator. The caret button raises it to the 20th power. Your N will equal 3,145,728. We're going to hold off on D. We're going to start or do D in our class. So just circle D, and we're going to talk about D, and we're going to go through D in our class just to verify and make sure that we know what's going on. Exercise number 2. Helmut from Finland is heading towards the lighthouse in a very particular way. He starts 160 feet away from the lighthouse. I want to underline that. He starts 160 feet. Okay, and the key word there is starts, my starting point. So before he moves, how far is he? 160 feet. So I want you to notice right here on my table where that looks like. On his first trip, he walks half the distance to the lighthouse. On his next trip, he walks half of that, what was left. On each consecutive trip, he walks half the distance he has left. We are going to model the distance d that Helmut has remaining to the lighthouse after n trips. So basically, now in the first one with the rumor spreading, we were getting larger. Now we're going to talk about decaying, and we're going to get smaller. We're talking about how much feet he has left to the lighthouse as he continues to walk, and we cut the trips in half. So let's go and fill in A. A says at 0 steps, he walks. He's at 160. After 1 step, he walks 80. After 2, he walks 40. After 3, he walks 20. And after 4, he walks 10. Or he's 10 feet away. C. Like in exercise 2A, we want to see the process as repeated multiplication by 1/2. Fill out each of the following pattern. Remember, the multiplying by 1/2 is the same thing as cutting it in half or dividing it. So we're multiplying by 1/2 each time. So 160 times 1/2 equals 80. 80 times 1/2 equals 160 times 1/2 times 1/2. That it's just written a little bit differently than how we did it on 2A or in the first exercise on the front page. 160 is our starting point. So in exercise 3, or number 3 here, it's going to be 160 times 1/2 times 1/2 times 1/2. Don't forget, this number 3 here, don't I want to see 3 1/2s? And I want you to fill in number 4, the pattern for number 4. How many 1/2s should I see there? So I want to see 160 times 1/2 times 1/2. Times 1/2 times 1/2, and I should have 4 of them. B. Each entry in the table could be found by multiplying the previous by what number? 1/2. This is important because we always want to think about exponential functions in terms of multiplying. So we never want to talk about decay as division. You're going to know that it's decaying, you multiply by a fraction. So you're multiplying by 1/2. D. Based on C, give the formula that predicts the distance d the helmet has left after n trips. So we're going to start with d equals my starting value, which is 160, times 1/2, because that's what we're multiplying by each time, raised to the n power. E, how far is helmet from the windmill after 6 trips? Provide a calculation that justifies your answer, and don't forget those units. So I'm going to say, all right, D equals 160 times 1/2 raised to the 6th power. Feel free to go ahead in your calculator and to do this. I'm going to tell you the answer. D equals 2.5 feet. We're going to talk about G, F, and H. G, F, and H in class.